Lesson 4.2, Translating Parabolas. Now, we've already talked about the standard form of a quadratic equation or a quadratic function. A, we said, tells us a little bit about whether or not it's going to open up or down. It also has another characteristic. It helps you decide the width of your parabola. Now, if you say that the graph of the parabola is going to be like that, we would describe the graph as being narrower if it's steeper, okay, or wider if it goes out wider on each side. The two green lines vary from the parent function y equals x squared. The a in this case is a 1. If a changes, meaning that it's bigger than 1 or less than 1, that affects the width of the graph. Now, I'm not sure why they discuss this here, because translations don't affect the shape. It only affects where it is positioned. But to go along with the book and your assignment, we'll discuss it here. Now, it says that the greater the absolute value of a, the narrower or skinnier the graph. So this parabola has a greater absolute value of a than this one or this one. In other words, it gets steeper faster or grows faster. So if we look at number 1, the absolute value of a is 3. That is greater than 1. Therefore, this parabola, if we were to graph it, would be considered wider. Or no, pardon me, narrower. Excuse me. Since 3 is greater than 1, this would be narrower. This is rearranged, so if we fixed it, it would look like this, where we have a 1. So the absolute value of -1 is, again, it's this number we're looking at, the a, is 1. That is unchanged. Okay, so this is not greater than or less than 1. It is the same. So this would not look any different, except for the fact that it being negative means it would open downward. But it is not narrower or wider. The next one, 2/3. Absolute value of 2/3 is 2/3. Now this is not greater than 1, therefore it's not skinnier. It is less than 1, so it would be wider. So narrower would go with this one, and wider would go with this one. And that's all we're going to talk about in terms of making it narrow or wider. Translations is our focus of today's lesson. And translations mean that if I have a grid with the parent function y equals x squared, it'd be centered and over the y-axis. Your vertex would be at 0, 0, and it's symmetrical, like I said, around the y-axis. Now we can translate that, and what we're going to do is we're going to track where that vertex goes. It should be at 0, 0, but we're going to see what happens to our parabola as we change the function. Now, everything in this box has an equation, or all the equations in the box are in what we call vertex form. All right, and that's going to be a very valuable form for us. Very similar to slope-intercept form. When it's in slope-intercept form, we can graph things easier. The same with vertex form. So the vertex form are specific to quadratic functions. Now notice that if you consider y equals ax squared, where a is 1, a parent function, this is centered at over the y-axis with the vertex at 0, 0. When you, inside the parentheses now, when you subtract a value, you think it would go to the left, but it actually goes to the right. When you add a value, it's moving it to the left. Again, quite the opposite of what you would think. If you are not inside the parentheses, in other words, not affecting x, but away from x squared, and you are adding a value, it does as it should. It moves the graph up. If you subtract a value, you move it down. So let's take a look at these examples. Notice again some key things. The x is being affected here. It's inside the parentheses and you are subtracting 2. As our table says, when we subtract something inside the parentheses, it moves it to the right and it moves it 2 units. Again, inside the parentheses, if you add 3, it'll go 3 units to the left. The last two, notice, very important, that you are not inside the parentheses. Therefore, you're not affecting x, which is left and right movement. Here you have plus 5. It's away from the x. It's not affecting x because it's not in the parentheses, so therefore it's actually affecting y, and it's going to move 5 units up. And then the next one again is not inside any parentheses, so it's affecting the y, and it will go -1, which means 1 unit down. So let's take a look at this. What is happening here? Well, inside the parentheses, it's affecting x. So this means you're going to move 3 units opposite of what you think. -3 you'd think would go left. This one's going to go right. And out here, it's going to go 2 units down. Next one, inside the parentheses, it's affecting x, so it's going to go 5 units left and 3 units up. So how do we write this function so it goes 4 units left and 3 units down? We would say y equals 5 parentheses x. We want it to go left 4 units, so we're going to add 4. We want it to go 3 units down, so we go -3. And one important thing that I forgot, the square above the parentheses. I'm going to stop it there. This ends part A, and I'll finish the next and last piece in part B.